So let's take a look at this Fluke multimeter. And although this is a Fluke 83 model series and we have Fluke 88s at the school, there are some things that are similar here. So first of all, let's take a look at the rotary switch, which is used to select the different operations or the different measurements. So this one here is for measuring AC voltage. This one is for DC voltage. This would be for measuring DC millivolts. This allows us to do a continuity tester, ohm tester, and capacitance, and we primarily would be doing probably ohms. This one is for diode checking. This allows me to check amperage and milliamps, both DC and AC. And then this meter has the ability to do microamps and also in DC and AC mode. So it's simply a matter of turning the rotary switch to the selection which you want to measure. And I want to point out that it goes into an automatic mode, so it's going to change the range automatically depending upon what you're measuring. It does list that you're measuring DC, it does list that you're measuring volts, and in this case it selected the 4-volt range right down there. There's a little 4 right there. And so it can measure up to 4 volts and down to a thousandth of a volt in this setting. If we switch to a millivolt range, we would now be able to see that we changed to millivolts here. We changed to 400 millivolts right over here. Let's talk a few minutes about these connections down the bottom down here. The common is going to be used all the time, and that's where that black lead goes into. So that's going to be common for all your operations, for everything that you do. These two connections are only if you're measuring amperage. This is for milliamps and microamps. It is fused, and it can do a maximum of 400 milliamps. So if you measure above that, you're going to blow the fuse, which are pretty expensive. This connection can do up to 10 amps maximum. It's also fused, and if you measure too much, you'll blow that expensive fuse as well. This red lead over here is going to be your primary stuff for most of the things we're doing with voltage, ohms, or diode check. So your lead would go into this one if we want to do something like a voltage, ohms, or diode check. The other two features, or other features that I want to talk about real quick, is this button over here, which switches to hertz, and on the Fluke 88 it also switches to a percent for duty cycle. So this meter does not do my percent. It does do my percent, however it's not listed on the button right here. And every time you push that button, it toggles between hertz, and it's listed right there, which is frequency, or percent listed right there, and then back to your regular voltage value. This button right here, this one does your range selection, and notice if I push that, it does DC range, but you see the dot or the decimal change, and it's now in the 40-volt range right here. Pushing it again gives me a 400-volt range, and the decimal moved again. Pushing it again gives me a 4,000-volt range, and there's no decimal displayed. And one more time will take me back to the 4-volt range. Notice that the auto has been gone, and that's because we are selecting our range. Pushing the range button and holding it down will put you back into an auto selection mode. The other feature I want to point out to you is this minimum maximum button. And this minimum maximum button can record your maximum and your minimum readings. And right now it is doing its recording. If I push one more time, it will display the maximum values that it's picking up. Pushing it again will display the minimum value, And one more time, it will give you my average value. So I'm not really measuring anything right now, so you can't see that in operation, but that is helpful when we're doing frequency or duty cycle to smooth out the reading. Holding it down will take it out of minimum maximum, and you'll notice that it didn't go into auto. If you want auto again, you have to hold it down to put it back into auto. The hold button will just simply hold whatever you have on your screen, so nothing new will change. So here I'm able with a stimulator to change the duty cycle, and I've got a percent over here. So if I move this potentiometer back and forth, it causes the duty cycle to jump around, making it a little difficult to get a real good fix on something that's constantly moving. This is where my min-max is going to come in, and you can hear it beeping as it updates. And if I put it on my average, even though I'm continuing to move the potentiometer back and forth here like I was a minute ago, you can tell that it's stabilized it because it's just giving me my average of around 82.9%. If I take it off of min-max, you'll see it jumping around again. So that would be the advantages of min-max. And if I wanted to hold something on the screen, that's the hold. You can see I'm still turning it over here, but nothing's happening because that held that value on the screen. So I'd like to take a minute to point out a measurement of ohms, and we're going to go ahead and select the ohms value here, and the OL stands for over the limit range. And so the leads are not touching each other, so the maximum measured value is well over what the capability of the meter is, and if we take these two leads and we short them together, we're going to get a resistance value of 0.2 of an ohm. So we're measuring that 0.2 because of the leads and the connections in the leads. If you want to zero that out, that's what that real value is for. So if I push that, that'll zero that value out. Now, if we want to make a measurement, such as in this electromagnet that I use in one of my other demonstrations, I'm simply going to connect the leads to this electromagnet, and you're going to see that the measured value of 0.5 of an ohm is for the resistance of this electromagnet. Now, if I took the real value off and connected the leads, you're going to see we're more like 0.7, because if you remember before, we had 0.2 in the leads themselves. A couple of last things to point out is if you put these leads in the wrong location, such as if I've chosen one of these amp values, and then I select voltage, listen, it beeps at you. Now the Fluke 88s will actually display the word lead across the screen telling you you have the leads in wrong. Well, they think you're going to measure voltage, but you've selected amperage, and you're going to burn that fuse up if you do that. If I leave the leads in the amperage and then I select amperage, well, then you won't get that beeping because now you've selected the correct setting for the correct lead position. And one last final thing to show you, there's a simple way you can check to see if these fuses are burned out. Simply take your meter and put your red lead in the red port for voltage and put it on ohms. Then take your red lead and remove the alligator clip so you have the pointed end. And you want to touch the top part of each amperage probe. So I'm just going to slide it in there. And if you get 1,000 ohms for the low amp side, and you get almost 0 ohms for the high amp side, This tells me that the fuses inside my meter are in good shape. If you get OL like this on either one of those tests, then you got burned out fuses.